Well, hello, Internet. How you doing today? My name is Guy Royce, and this is Redis Monthly Live. We call it Redis Monthly Live because I lack imagination. It's all about Redis. We do it every month, and it's live. Today, we've got Nava Levy with us today. Can I say today more than once? And she's going to be talking to us about, here's our agenda. Let's go through our agenda, shall we? Nava's got a talk, ML feature stores with Redis, past, present, and future. So you want to tell us what your talk's about today, Nava, more than just the title that I've proffered here?
Well, this is thanks, Guy, and this is actually one of my favorite topics. It's about feature stores for machine learning, and we're going to talk about feature stores, the role of Redis in feature stores, some trends, past, present, and future, and how to get started with feature stores with Redis using two great open source feature stores, one named Feathr and the other one Feathr.
Excellent. I actually haven't looked at the Redis as a feature store use case feature thingy that we're doing here. And so I'm actually looking forward to this talk quite a bit. So I'm glad you're doing it. Even though, and just for the record, everyone, Nava's coming to us from Israel. So it's, 9 p.m. for you right now? So, yeah. And she's still at the office, and that is dedication right there. So we got someone in the audience here saying hello. So hello, I see you. So
Hi.
Thanks for tuning in. So let's see, what do we got? There's always a little bit that I like to do here, where we sort of, I call it paying the bills, but we're all with Redis, so this is the bills, right? But we got some events coming up here on Redis Live. We got a big streaming series coming, and so I realize we're halfway through April already to have an April streaming series, but starting tomorrow and every weekday this month, Brian Samboden, Steve Laurello, Simon Prickett, and myself will be doing live streams right here on this channel here. We will, on Twitch only. So if you're watching from Twitch, you can see us on Twitch. We won't be streaming it on YouTube. But we're going to do a whole bunch of streams. Brian's doing some stuff with manipulating JSON documents with entity streams, which is apparently some Java thing that people care about. Steve is doing a real-time stock analysis with Redis Stack and .NET. Simon, always the overachiever, is going to be doing 3 different topics on 3 different days. You can see them here on the screen. And I'm going to be doing, I'm going to track aircraft with software-defined radio and Redis streams. And so I think that'll be a lot of fun too. So we've got a lot of fun streams coming up. We want to fill up this Twitch channel. If you want to make sure you see those, go to twitch.tv/Redis and give us a follow. And you can see this whole schedule up at meetups.redis.com/RedisLive. So go check those out, please. I know that when I stream, I like to have an audience. That always makes it more compelling. We have another hello from the audience here too. So hello, good to see you. It's always nice to know that you all are out there. It warms my heart. So, and that's pretty much the opener here. So, Nava, I usually like to do like a sort of a chit chat, sort of time waster at this moment here, where before I kick your talk off, I usually try to ask some sort of random question about Redis, like I often do, what's the weirdest use case you've ever used Redis for? But I think I'm going to go with, what's your favorite Redis command? And I didn't tell her in advance that I was going to do this.
Actually, I can't think of one. I maybe all of them are awesome,
Everything is awesome, right?
Yeah. And every time I learn a new command, so it's great. It's just it's more and more. It's so rich, and there are so many options and data structures, and it's really exciting. Maybe I didn't mention it, but other than being a developer advocate at Redis for machine learning and AI, I also founded an edtech venture, Lergo, that is actually using Redis. And in front of MongoDB, and this is what people traditionally thought of Redis as a cache, to make the application much faster. And today I see so many use cases for so many applications as Redis as a primary database and data structures. And so, it's really, really awesome.
It is cool. There's what I find is that Redis has a lot more than, like, everyone says, oh, it's just Redis is a cache, Redis is a cache. And the honest truth is Redis makes a fantastic cache. It's really good at that.
Yeah.
The most common use case is just, well, I'll store something as a string and I'll just use it as a cache. And there's a lot more data structures there. And it's not just hashes and strings and sets and lists. There's, there's streams, and you can do pub sub, and then with the modules, you get all these features. Redis AI adds tensors if you want to store n-dimensional numeric data. JSON lets you do JSON documents. There's a ton of cool stuff. I think if I had to pick my favorite myself, I actually like the geoset. There's just something kind of neat about the geoset. I don't know why that. I've always liked maps. I think that's what it is. So,
cool.
But anyhow,
I'm going to be talking a little bit about data structures and how they can be leveraged also in the context of feature store. So, it's really exciting.
Cool.
It's going to be the impact is amazing.
Cool. Well, that's a good segue to actually kicking off your talk, isn't it?
Yeah, sure.
Perfect. Well, here, I'm going to go ahead and put you on screen here. There you go. And the floor is yours, Nava.
Okay, thank you, Guy, and thanks everyone for joining this session. And I'm very happy to be here to talking about feature stores. And let's begin. So we'll talk about what are feature stores with Redis, some trends, and how to get started with Feathr and Feathr. So let's get started. So when we talk about, we think about AI and machine learning or use cases in production, we see that there are many use cases that we are all familiar with. Some we interact on a daily basis. So if it's, in entertainment, video recommendation, or TikTok or YouTube, or if it's for healthcare, medical diagnosis, or image classification, does he have pneumonia or not? If it's for financial segment, fraud detection, loan approval, for manufacturing, visual inspection, predictive maintenance, and so on and so on. And when we look at those use cases, especially over time, we see that more and more of them are becoming real time. And when they become real time, they have much more value to the end user and to the business, and they become much more mission critical. And this is the area that Redis plays in, the real-time AI. And we have two focus areas in the intersection between embeddings and real-time AI, and this is relatively a new offering, vector similarity search or neural search, and it has tons of applications that are very exciting. And for several years now, on the intersection between real-time AI and feature store, which is online feature store. And this is really what we're going to talk about here today. The online feature store that reside in the feature stores, and they are becoming a very important component for machine learning operations or MLOps platforms. And why do we need a machine learning operations platform, or what are they? So deploying machine learning in production is very hard and complex. A lot of those models really don't make it to production. Some companies never successfully manage to deploy a model in production. And even after some models are successfully deployed in production, they crash and burn afterwards, after a while, because things like data drift, concept drift, or other performance issues. So what we have is the domain of MLOps, very similar to DevOps, that bridges the gap between, what a data scientist developed in his Jupyter notebook and what is needed for deploying a use case in production. So, and this is the machine learning operations platforms, and they are very important. And feature stores are emerging as the cornerstone cornerstone of machine learning operations platform, and we'll see soon why is that. So what are feature stores and feature stores with Redis? So feature stores are really data stores. And in machine learning, a feature is just a fancy way of saying data input for the machine learning model for inference. And feature engineering is the process of extracting those features from raw data. And when we want to feed a feature or a feature vector, which is a vector of floating point values, numbers, to the machine learning model, we need to do the process of feature engineering. And here you can see from developers.google.com an example for features for a machine learning model for predicting the pricing of a house. So we can have a feature or input data of number of rooms, number of bedrooms, which are relevant for predicting the price of a house. And then we need to convert it into to real numbers for it to be processed by the machine learning model for training and then for inference or for prediction. And here, if you're not familiar, inference, prediction, classification, scoring, serving are more or less the same things. Now, when we look at the machine learning engineering process, scoping, data management, modeling, training the model, choosing the right model, and deployment, then we see that most of the time that a data scientist spends on is the data management or feature engineering. And really, most companies see that the data collection, pre-processing, transformation, feature engineering is really a bottleneck or one of the biggest bottlenecks in productizing machine learning models in a timely fashion. So this is why feature stores that manage features or manage the data inputs are so important. And so what are feature stores? Feature stores sit between the raw data and the model. And you have the raw data, you engineer features, you feed the features into the feature store, then you extract those features for online predictions, and you use those features also for model training and batch predictions. And the objective of a feature store is for real-time applications is the most important objective is serving features very fast for predictions with low latency. And the other two objectives are avoiding training serving skew. There is a skew when we train a model and we reach a level of accuracy, and then we deploy to production, usually there is a deterioration in accuracy, and we want to minimize this deterioration. And the reason there is a skew is because features defined for training slightly different than in production, and those slight difference make a huge impact. And the feature helps us avoid this skew, and we'll talk about how. And the feature store also allows data scientists to share features between machine learning use cases. Other data scientists can go to the feature store, search and discover features that can be useful for their own use case instead of developing those features from scratch. And I'm now going to focus on the first objective, which is so important for real-time AI and machine learning. And this is also the area that Redis is more prominent with the online feature store. So when we talk about real-time AI and machine learning, what do we mean? So what we mean is that serving prediction in real time upon receiving an online request from an operational system, from an app or a website, as the user interacts with the app, as he performs a search or makes a purchase based on live, fresh, real-time data. So if in the past real-time wasn't based on live, fresh, real-time data, maybe it was data from a day ago or from an hour ago, today real-time is defined as online predictions that are based on the most recent data that is available. And that makes the predictions much more accurate and the whole use case much more valuable. And doing it extremely fast with a very low latency. And when we say very low latency, this is something that has been evolving over the years. So if let's say for fraud detection, It was doing batch scoring or batch predictions once every 24 hours was completely acceptable. 3 to 5 years ago, the window moved to, let's say, 40 minutes. And 2-3 years ago, or the online scoring was somewhere between 200 milliseconds and 12 seconds. And if you think 12 seconds, now that's not really real time. So I saw a use case from about 2-3 years ago about a company that moved fraud detection from a window of 40 minutes to 12 seconds, and there was a huge return on investment. I think the ROI was after 3 months, and this is because we move from fraud detection to fraud prevention if we can stop it within 12 seconds. But today, when we say real time, we really refer usually to somewhere between 50 milliseconds to 200 milliseconds, and examples like that are AT&T for fraud detection and Ekata for transaction risk API, 50 milliseconds and 100 milliseconds. And this end-to-end latency is comprised of a number of components: the network latency, which could be anywhere between 20 milliseconds to 70 milliseconds, application pipeline, feature serving, and model scoring. And the sum of this has to be less than, let's say, 100 milliseconds or 200 milliseconds, whatever the end-to-end latency. So usually that means that, for instance, for feature serving, it has to be less than 50 milliseconds and sometimes less than 20 milliseconds. And for this to happen, you need the data store latency or the read latency sometimes to be less than a millisecond and definitely less than 10 milliseconds. So this is basically how fast this has to be, and this is really not trivial. So when we look at the data pipeline for real-time AI and machine learning, so we have the raw data, and the raw data is usually comprised of two sources. One is the batch sources, and one is the streaming sources. So the batch sources could be from our data warehouse, and the streaming sources are the live, fresh data. Maybe it's a click stream, maybe it's an IoT device, maybe it's server logs, maybe it's the last transaction or a series of transactions. And then we do feature engineering, and here you have to make sure that you have a robust streaming transport. Maybe it's Kafka or Kinesis, and streaming computation. Maybe it's Flink or Spark. And for feature serving, what method are you using to extract the feature from the data stores? Is it a Java gRPC server? Is it a HTTP server? Python server? Is it maybe it's just an AWS Lambda function? So every choice you make will have some implication on latency, and each component can be optimized. Also, the inference component can be optimized. Which inference server are you using? Are you using hardware accelerators, GPUs? Is the model optimized? Maybe it can be smaller. Maybe the inference can be done in memory in the data store, and you don't have to waste latency or time on extracting the features. So all this can be optimized. And what we found is that the online store, the data store that you store the features for online inference is one of the most critical components. It often is a bottleneck for deploying real-time AI machine learning at scale. And it's often the Redis is most often chosen for this component because it's an in-memory data structure. And if you want to go more into the details why Redis is chosen, then I think that the answer is benchmarks. Because it's such a critical component, companies perform thorough benchmarks before they select the data store for the online store, or often called the online feature store. And often they share those benchmarks with the community. So here I'm going to share benchmarks from Uber, from Feathr, which is a very popular open source feature store, from Tekton, which is a commercial feature store, and DoorDash, which is a very successful company deploying real-time AI machine learning at scale. So you can afterwards pause this video and read those quotes to see why Redis was selected, and also there are links to the benchmarks themselves that you're welcome to read. But in general, Uber found that Redis is much more cost-effective compared to Cassandra for certain use cases. So some of its feature sets, it moved over to Redis. And Feathr found that compared to AWS DynamoDB and Google GCP Data Store, Redis was significantly more performant. And Tekton did a benchmark with Redis Enterprise and compared it to AWS DynamoDB and found that Redis Enterprise is 3 times faster and at the same time 14 times less expensive compared to DynamoDB. And DoorDash did a benchmark and compared to 3 or 4 other key value stores and found that, again, Redis was the most performant, so high throughput, low latency, and also the most cost efficient. So these are really why Redis is so often selected as the online feature store for the feature store, as the infrastructure for the online feature store for a feature store. And it's not just the low latency, high throughput, and being cost efficient. It's also about the flexibility that Redis enables with the many data structures, as Guy and I talked at the beginning, and that makes the developer experience much faster, much more developer friendly. So when you can use the right data structure for your use case. And it also has a lot of benefits in terms of cost and performance. And this is talking about DoorDash. They wrote an article in DoorDash Engineering from November 2020, and they explain how by moving from a flat list of key value pairs to Redis hashes, they were able to significantly reduce the cost. So I'll just explain a little bit. So if I took the examples that we discussed before for predicting the pricing of houses. So we have the feature input, number of rooms, number of bedrooms, and it's a feature data frame, basically a table. And if you want to extract a feature vector, one row, then we can do it in a number of ways. If we do it that each feature, number of room is a key and the number of bedroom is a key, then we have multiple commands, get to get those features. But if we implement it using Redis hashes, then we have a single command in which, and the key is the house info. So here, house info 1000, and we can get all those features. And usually, there are not just 2 or 3 features, there are many more. There could be hundreds of features. So this is a huge saving. And with the benchmark that DoorDash performed, they found that by implementing Redis hashes, the latency dropped by 40%, and they saw 5x improvement in CPU efficiency, and also the memory footprint was much lower. So this translates to much lower cost. So this is just one example. In the Ikata example that I mentioned earlier, they are using sorted sets to implement the identity graph data, and we see other companies using Redis JSON and the Redis Bloom for having a much more space efficient feature stores if the accuracy is not so important. So there are many options of using data structure that fit the specific use case that you are working in, and Redis supports them. So if we think of why Redis for online feature store, so we talked about the scale, the low latency, the high throughput, the different data types and structures, and being persistent with snapshot and AOF, append-only file. And we talked about the data structures and the benchmarks, but we see that if you want to have the high availability or 5.9 availabilities, and you want you want the global to enjoy or benefit from global distribution, if it's to reduce the network latency or from regulation perspective, and if you don't want the headache of managing Redis clusters yourself, and if you want to scale cost effectively when you have terabytes of size data sets, then often companies move from Redis open source to Redis enterprise and Redis enterprise in the cloud to enjoy all of these benefits. And scaling cost effectively, it's something that is done very effectively with Redis on Flash. And it's a tiered memory architecture between DRAM in memory and the SSDs, and you can save up to 80% of the cost, and you distribute between the hot features and the warm features between the in memory, the DRAM, and the SSD. So these are really the reasons why when you scale your feature store, you can do it with Redis. You start with Redis open source, and then you scale with Redis Enterprise. And we talked mostly on the online feature store, and DoorDash is an example that the feature store was just comprised of the online feature store, and the objective was serving features very fast for real-time or online predictions. But in later articles and presentation, they talked about a feature store having two components, the offline store and the online store. And this is when the feature store has the other objective that I mentioned earlier, the other two objectives. And the offline store is used for model training and for batch predictions. And if before DoorDash, if the DoorDash implements the offline store with Snowflake, we see that there are other options to implement offline store, and we'll talk about them. For the online store, the online store stores only the latest features, while the offline stores static and historical data. And because it's used for training and batch prediction, there is no strict latency requirement. So there are many options for implementing the offline feature store. It could be Snowflake like DoorDash, and it could be Amazon Redshift, and S3, Amazon S3, Google BigQuery, SQL Azure, etc. And Redis, as I mentioned earlier, is the most often selected for the online feature store, and it's a critical component for real-time data layer for machine learning and AI. Now, the management or the orchestration layer, this is the component that is responsible for the other two objectives, avoiding training serving skew. So how do we avoid the skew? By defining in the registry the features on the logical level. So the same definition is used once for offline, for the offline store or for training and batch predictions, and one for the online store. And this way we avoid the training serving skew. And once the features are defined in a logical, the transformation logic and the features that are defined in a center place in the registry, then they can be reused not just once for training and once for prediction, but also across use cases by the same data scientist that created them or by another data scientist in the organization. And this way, a feature that is used for many use cases can be shared across use cases, and the data scientists don't have to build this feature from scratch again and again and again, and that's a huge cost saving, and it increases the time to market. So this is very important. It saves cost and it improves accuracy, and it's much faster time to market. It's no longer a bottleneck. So if we think of the role of Redis and Redis Enterprise in the real-time AI machine learning, then here are some of the logos, very, very impressive logos of companies that successfully deploy real-time AI machine learning, and they leverage Redis for the online store. So you can see that they are globally distributed from many verticals. So if In financial services, we have a Kata and Better for online mortgages and Robinhood for stock trading. And there are also banks not mentioned here that use Redis for the online store or for serving features very fast. And if we're talking about media and communications or telecom, then AT&T and Comcast. And if we talk about the food tech industry, so we have Zomato and Swiggy and iFood, and so the ride hailing. So we have Gojek and we have Uber. So there are many verticals who use real-time AI, and they rely on Redis for the online feature store. And these are the end users. But we see that today also companies that are offering feature store, if it's open source feature stores or commercial feature store or cloud-based features, are relying on Redis for the online feature store. And here you have some of the names. And the Feathr is we're going to talk later about Feathr, which is a very popular open source feature store. And we're going to talk about the Feathr, which is the newest kid on the block. And it's the battled, many years feature store of LinkedIn that battle tested for many years in production and at scale, that they are now open source, so we can use them, and it's really very exciting announcement, and we talk about also Feathr later on. But before we do that, let's first talk about some of the trends that we see with feature stores, feature store past, present, and future. So when we talk about maybe if there are any questions, or I'll take questions maybe towards the end. Okay, so so we're going to talk about the first about the feature store functionality and capabilities. So if in the past, the capability of feature store, we saw the features emerging from companies offering real-time AI machine learning, and the primary objective was real-time feature serving. That was in the past. DoorDash is an example. Other companies, maybe they didn't even have real-time AI and machine learning, let's say 5 years ago, okay? And what was important for them is improving the efficiency, the time to market of models to deployment, and not reinventing the wheel every time a data scientist needs a feature. So the feature registry, the center place or the marketplace of features, was very important. So that was in the past. Today we see that most feature stores are really have those. Just a second, I clicked once too many. I don't know. Okay, so please ignore the future. So we see that the three objectives that I mentioned earlier, most of the feature store today address, but there is a large variance in implementations and architectures, and large variance of other functionalities that are implemented. But all of them, have real-time feature serving. All of them have some mechanism for integrity and avoiding training serving skew. If it's a unified pipelines, define the features once for both training and production, and point-in-time correctness to avoid leakage, or what we call time travel, and the feature registry to share features across use cases. Looking in the future, and this is from talking to customers and hearing case studies, and what we see in the future, and probably there are many more other possibilities that we didn't capture in this short list. But definitely feature store will have to be enterprise grade in terms of five-line availability, scalability, persistence, regulations, privacy regulations, security, monitoring and explainability, which are becoming more and more important. So monitoring the features for drifting distributions, the input features, the predictions, feature transformation and computation. Not all feature stores today includes definition of feature transformation and the computation agent to perform those transformations. I think it's very important that there will be inside the feature store support for real-time features. So I mentioned streaming, and most feature store today support both batch sources and streaming sources, but not everyone support real-time features, and real-time features are features that the features can be calculated only at inference time. So for instance, if I have if it's a transaction fraud, and I have the location of the current transaction, and I have the location of the last transaction from streaming sources, I can calculate the distance from last transaction, and this is a real-time feature that can only be calculated at inference time, at the prediction time. So support for real-time features are very important, and some feature stores already support it. Embeddings that are becoming such a huge thing as a first-class citizen. So the same way that any feature we can discover, we can monitor, and we can explain. Also, we can do also for embeddings and perform standard operations on embedding vectors. Streaming first architecture, as I mentioned, some of the feature store started from supporting batch prediction use cases, and streaming it was kind of an afterthought. So, and this is what led to the skew, the serving training skew. So, having a streaming first architecture, looking at batch as a particular case, a subset of streaming, is something that is also a lot of companies looking at. Intuitive UI to support citizen data scientists. So citizen data scientist is a trend that is all over, not just feature store, and feature store is no exception. And automation, wherever you can, if it's for anomaly detection, if it's for cost efficiencies, if it's to detecting data drift, if it's for recommending features, all of it, anything that can be automated, or backfill automation for creating the training data sets, all of it would be beneficial for the feature stores in the future. And when we look at the use cases, so as I said, in the past, feature store supported either real-time use case or batch predictions. Today we see that it's more of both, and the throughput is becoming higher, and the data sets are larger, in the terabytes. In the future, we expect all feature stores to support online predictions. All or almost of online predictions will be based on live, fresh data, streaming plus real-time features, use cases to scale to many terabyte size datasets. So for instance, in the Ekata use case, it's 10 terabytes, but we'll see more of those kinds of use cases and much more than 10 terabytes size datasets. And the very high throughputs, millions per second and more mission critical use cases. So for mission critical use cases, important the 5.9 availability and persistency and so forth. So all of these have implications also on the online feature store. So if in the past low latency features are materialized from batch sources mostly, and only for the high-end feature stores we saw the streaming sources and the strict latency and throughput requirements. Today we see more and more such requirements for very low latency. Feature time to live is important when you have streaming features that you don't want them to just be in the feature store and waste the storage. You want them to be expired and evacuated. So time to live, what Redis has, TTL is very important. High throughputs, 4 to 5.9 availabilities, and different data structures, easy to manage and scale. Most companies find today that really this is not what they want to be doing. They want to focus on their core business and not managing infrastructure, and to scale cost effectively. And in the future, 5.9 availability would be like a prerequisite. Persistence will be key. When you have large terabytes data set, reducing costs with tiered memory access between DRAM and flash that I mentioned earlier will be important. Leveraging creatively data structures to improve developer productivity and improve performance and reduce costs will be key. Multi-cloud geo-replication, no vendor lock-in will be very important. Transformation and feature engineering to be performed even in memory is something that I think people will look at. And also maybe inference in certain cases will be performed in memory in the online feature store. And to implement that, if in the past Redis open source was enough, today we see more and more companies choosing Redis Enterprise. And in the future, we think that more and more companies will choose Redis Enterprise with Redis on Flash and leverage also the multi-cloud capabilities and other capabilities that Redis Enterprise has today and will have in the future. In terms of build versus open source versus buy, build from scratch, open source buy. So if in the past, all implementations, or almost all, were do-it-yourself, built from scratch, and we saw the beginnings of open source. So Gojek, a ride-hailing company, open sourced their feature store, and that led to Feast. So today, we see that open source is getting more popular, commercial feature store emerging, and they're becoming more mature and with more functionality like Tecton and Quark and H2O and Cascada. Feature stores offered on all the major cloud platforms. And here I mentioned 3 use cases of open source feature store. And if you Google them, you will find those use cases online. And maybe we'll also add the links to the recording of this on YouTube of this presentation. And in the future, we expect to have enterprise-ready open source options available on cloud platforms, and these will dominate. And I think that the introduction of the battle-tested feature store of LinkedIn, Feathr, is an example in that direction. And small, medium enterprise will opt to buy. They probably won't see why should they buy, even if it's open source. So we expect them to go to commercial options. So this is what we expect in terms of the future. And so how can we get started? This we talked about what are feature store, what is the role of feature store, the role of Redis with feature store, which is the infrastructure for the online feature store. And we talked about some trends for the future. And so now, how can you get started? So we will give some tips on how to get started with the open source feature store of Feathr and Feast. And basically, because they are open source and Redis is open source, even today, 10 minutes after this presentation, you can just, open a Jupyter notebook or a Google Colab and try a Feathr or Feast yourself. So let's get started. So here we see the Feast data infrastructure, and you can see that the online store, the features are materialized or loaded from the data warehouse or from batch sources. But Feast also supports streaming sources. With Redis, it's only supported for Redis as the online feature store. And we have also a quick start tutorial that we prepared. And you can see here on the right the tutorial steps. And the tutorial you can run locally, and you can also open it in Colab, in Google Colab. And so it's really easy. It walks you step by step of all the commands. And there is also a Slack channel of Feast that if you have any questions, you can go and ask questions, and the response is very fast. You can also deploy Feast on Microsoft Azure, and it's integrated into the Azure data and AI ecosystem. So if you're an Azure customer, this is a really good option for you. And this way, you can also enjoy the enterprise tiers of Azure Redis with the 5.9 availabilities, the data structures, the global distribution, and reducing costs with enterprise Flash. And also for Feast on Azure, there is a very good tutorial, and you can see the link here, and we'll add those links again to the recording on YouTube of this presentation. And Feathr is, as we said, is the new kid on the block. It's been in production. It's a feature store that LinkedIn open sourced, and it has been in production to 5-6 years in LinkedIn at very large scale, very high velocity and high throughput for many users. And so you can see here the architecture of Feathr on Azure. And it's a scalable, enterprise-ready with native Azure integrations. It has many important features, like, for instance, defining the transformation, computing those transformations, the feature engineering in the data store, support for real-time features, and many other features that enterprise-ready feature store need. And again, you can leverage the enterprise tiers of Redis on Azure, the Azure cache for Redis, with active and flash and all the good stuff that we mentioned for the enterprise tiers of Redis. And also, Feathr created a very good quick start tutorial. You can see the link here. We'll share the links in the recording of on YouTube, and there is also an active Slack channel, featherai.slack.com, that you are invited to join. And if you have any questions or run into any issues, the people there will be, the community will be happy, the Feathr community will be happy to help you. So this is basically concludes my presentation. We saw what feature stores are, the role of Redis in feature stores, some trends, past, present, future, and we saw how to get started with two great open source feature stores, Feast and Feathr. So if there are any questions, I'll be happy to answer them now.
Thanks, Nava. I actually am not seeing any questions in chat, but that's fine. It's a lot of information. If you have any questions, we're sort of filling air right now to allow for lag in case you have any questions. Go ahead and drop them in chat. And if we don't get to your question, go ahead and drop it in a comment on the YouTube video, and we try to loop back around and answer them there too. So yeah, that's pretty much all I got on questions. Have I stalled enough that there are any questions? I don't see any, so it's all good. So thanks, Nava.
Thank you for hosting me, Guy.
Yeah,
I'm very happy to be in the Redis Monthly Live, and you can see my email here, and you can also connect with me on LinkedIn, and we can chat offline.
Absolutely. So do you still have electricity? Before we got on stream here, Nava was telling me that the power goes off at the Israeli office at 10 p.m., which is in how many minutes? Yeah. Which is in 11 minutes. So we're going to be done in 11 minutes, whether we want to or not, right? Well, here, I'm going to go ahead and bring this up. So just to point out, again, everyone, thanks for attending Redis Monthly Live today and watching with us. Again, if you have any questions, go ahead and drop them in a comment in the video on YouTube, and we'll circle back around and check those. And go check out all this wonderful real-time AI stuff. It's pretty neat. Next month, we've got Brian Gorman coming in from, I think Brian's based out of St. Louis. I've known Brian for quite a while now. He's a fellow speaker on the conference circuit here in North America. And he's going to be doing a talk on optimizing and scaling your .NET Core apps with Azure and Azure Redis Cache. So that's certainly something to come and check out. Anything that can make your stuff faster is always good. So Brian is here next month, May 16th, 2 p.m. Eastern Time, 8 p.m. CET. And yeah, that's what we got for next month. And I've got another slide here. There it is. I knew I had another slide. There we go. And if you want to make sure you catch Redis Monthly Live, and for that matter, all of the streaming that we're kicking off here in April for starting tomorrow, give us a follow on Twitch, twitch.tv/RedisInc, and just give us a follow there. You'll get an email then from Twitch whenever we go live. You can subscribe to our YouTube channel and get not only Redis Monthly Live, but lots of other content that we produce on that channel. And of course, join our Discord server. It's where myself and a lot of us developer advocates hang out and answer all your questions and have conversations about Redis and the modules and all the features and the libraries that we've written around it. So check that out too. If you want to talk to me directly, that's probably the best way to do it. So, and of course, if you want to get notifications of all the things that are happening on Twitch and YouTube live, go to meetups.redis.com/redislive and you get the full schedule of what's coming up both on Twitch and on YouTube. And that is pretty much that. Oh, I always forget this one. This is sort of like our online virtual meetup. And, you know, as a meetup organizer, I always need speakers. I like having people like Nava from inside of Redis online on stream. But what I like even better, sorry, Nava, is people from outside of Redis. So if you have a Redis talk that you'd like to give, I'd like to hear about it. So go ahead and drop me an email, guy.royce@redis.com, or hit me up on Discord, or just hit me up on Twitter and say, hey, I'd like to speak on Redis Monthly Live, and we'll make that happen. So, and that is a wrap. That's all we've got. So thanks a lot for watching, everyone. Thanks, Nava, again for speaking.
Thank you.
And do you have any final words you'd like to say?
Just I'm looking forward to see what people are going to do with Feature Store and RealTime AI. It's all so exciting, and that's it.
That's probably one of the best things about building technology is seeing what other people do with it. It's like the best and the worst thing, actually.
Yeah, I'm always so surprised. I'm always, blown away by what people are doing. So
mostly there's a ton of cool stuff. Every now and then you see someone using it. It's like, I had no idea that. I never envisioned that at all, which is surprising. And sometimes it's like, no, that's not how it's supposed to be used at all. You do not use a fork as a screwdriver. So, but it is very exciting. So, well, that's it. So thanks a lot, Nava. Thanks everyone else.
Thanks, guys. Thanks everyone. Bye-bye.
And see you all later.